Right now, tens of millions of people across Europe are living under a weather pattern that meteorologists describe as a classic omega block, a towering ridge of high pressure sitting directly over the heart of the continent, flanked by two deep, low-pressure systems, one out over the North Atlantic and one parked over Russia, together forming a shape on the pressure map that genuinely resembles the Greek letter omega. That configuration has been locking an intense heat dome in place across Europe since late July, and according to meteorologists tracking it, this is already the fourth major heat wave of the summer of 2026. High-resolution weather models are showing mid and upper atmosphere thermal anomalies pushing into the 99th percentile, the kind of statistical extreme usually reserved for describing once-in-a-generation events. And forecasters are warning the heat dome could expand even further by the middle of August rather than break down anytime soon. This has been the reality across most of the continent for weeks now, and the pattern is only just beginning to shift. Let's go through this phase by phase, because the story of Europe's weather right now is really a story in two acts. The brutal, record-challenging heat that has already gripped the continent through late July and into early August, and the genuine pattern change forecasters are now tracking for the back half of the month, one that could bring real relief to some regions while shifting the worst of the heat somewhere else entirely. According to meteorologists at Severe Weather Europe, the current heat dome is forecast to engulf most of the continent with excessive heat stretching from Iberia through France, Germany, and the Baltic region, and further south across Central Europe and the Mediterranean, hitting at the exact moment when tens of millions of vacationers are packed into those same regions for peak summer holiday season. Temperatures at the 850 millibar level, a standard atmospheric benchmark meteorologists use to judge the underlying severity of a heat event independent of local surface effects, are forecast to push into the range of 24 to 28 degrees Celsius across a broad swath of the continent, a reading forecasters specifically flag as particularly extreme, since values in that range are typically only seen during the very worst heat waves any given region experiences in a given year. It's worth spending a moment explaining exactly what an omega block is and why meteorologists consider this particular pattern so significant, because the shape itself carries real meaning about how long a weather event is likely to persist. Under normal conditions, the jet stream, the fast-moving river of air circling the planet at high altitude that generally steers weather systems from west to east, flows in a relatively smooth, wavy pattern, allowing high and low pressure systems to move through a given region over a matter of days before giving way to the next system in line. An omega block disrupts that normal progression entirely. Instead of continuing to move eastward, the jet stream buckles into a shape resembling the Greek letter it's named for, splitting into two separate branches that flow around a stationary ridge of high pressure sitting in the middle, with a deep trough of low pressure parked on either side. Because that configuration is, by its underlying physical structure, considerably more stable and self-reinforcing than a normal, flatter jet stream flow. Omega blocks are notorious among meteorologists for persisting far longer than an ordinary weather system would, sometimes for a week or more, occasionally considerably longer, effectively trapping whatever weather sits beneath the central ridge in place for an extended stretch, unable to be dislodged by the incoming systems that would normally move it along. That is precisely why this particular heat dome has proven so durable and why forecasters have specifically been monitoring the possibility of it expanding further into mid-August rather than breaking down quickly the way an ordinary summer hot spell typically would. For most of Central Europe, meteorologists say a realistic upper range during major heat wave peaks now sits somewhere around 32 to 38 degrees Celsius, though localized readings above that range remain possible and can generally only be forecast with real confidence a few days out from the actual event. According to the seasonal outlook platform Pogodnik, Europe is approaching the heart of August, after an already exceptionally warm and dry start to the summer across many areas, with Western, Central, and Southeastern Europe having already endured multiple heat waves, sharply reduced river levels, wildfires, and severely depleted soil moisture even before this latest heat dome fully established itself. That accumulated deficit matters enormously for how the current heat wave actually plays out on the ground, because even a moderate additional hot spell can hit considerably harder than it otherwise would when it lands on top of soil, rivers, and vegetation that are already running. Dry, and any short, isolated thunderstorms that do break through are unlikely to meaningfully reverse that accumulated water shortage. It's worth pausing here to explain exactly what's driving this pattern, because a genuine, credible link is now being drawn between what's happening in Europe's atmosphere and a much larger ocean-scale climate signal thousands of miles away. According to Severe Weather Europe's most recent tracking, the 2026 El Niño event is rapidly intensifying, with some forecasts pushing toward what meteorologists are calling a potential super El Niño, a term reserved for El Niño events strong enough to meaningfully reshape weather patterns across large portions of the globe, not just around the tropical Pacific, where El Niño itself originates. El Niño works by altering ocean, surface temperatures across a huge stretch of the equatorial Pacific. And those shifts ripple outward through the atmosphere's broader circulation, nudging jet stream positions and pressure patterns across entire hemispheres in ways that can, among many other effects, help lock persistent ridges of high pressure in place over regions like Europe for extended stretches at a time. Researchers have also pointed to a broader, independent trend layered on top of any single El Niño event. A study published in the Proceedings of the National Academy of Sciences found that the specific kind of atmospheric blocking patterns responsible for locking in extreme weather, whether that's a scorching heat dome or a stalled flooding event, have nearly tripled in frequency in recent years, a trend researchers connect to the broader changes reshaping the atmosphere's large-scale circulation as the planet continues warming. Regionally, the picture varies considerably depending on exactly where you are on the continent, and it's worth going through the specific hotspots one by one. According to Ioana Vergini, founder of the weather forecasting platform WFY24, speaking to Euronews Earth in late July, the earliest seasonal outlooks for August all agreed on tilting the odds toward a warmer than normal month across essentially the entire continent, with the strongest and most confident heat signal sitting specifically over the Mediterranean and southeastern Europe. Vergini specifically highlighted a set of recurring heat clusters worth watching closely: Iberia, meaning Spain and Portugal, along with Italy, Greece, and parts of the Balkans, all regions already accustomed to intense summer heat, but now facing the prospect of a summer running measurably hotter, even by their own demanding standards. Separate detailed forecasting from markvoganweather.com, updated at the very end of July, sketched out a similarly complex, shifting regional picture for the month ahead. Heading into the first half of August, the heat core was expected to focus primarily on central, eastern, and southeastern Europe, with a genuinely major heat wave likely developing across that stretch, while temperatures in the 30s, and in some spots, even the low 40s Celsius, were expected to build across eastern and southeastern Germany, Poland, and Romania. At the same time, northwestern Europe, including southeast England and northwest France, was expected to see a somewhat different pattern unfold after an initial spike in heat, settling into steadier conditions in the mid to high 20s Celsius through the first half of the month, while Ireland and Scotland stayed comparatively cool, generally in the high teens. That kind of sharp regional gradient, intense, dangerous heat concentrated over Central and Eastern Europe, while the Northwest experiences a milder, if still warmer than average pattern, is a hallmark of exactly the kind of large, sprawling, blocking high setup currently dominating the continent's weather. Looking further ahead, into the second half of August, forecasters describe the outlook as considerably less certain, though there are meaningful hints of what's coming. Some signals point toward the ridge of high pressure currently anchored over Central Europe gradually shifting and pulling further south and west as the month wears on, with rising heights building across the north. Atlantic before that ridging pattern extends back south toward Europe, again closer to month's end. If that shift plays out as currently signaled, it could bring another significant round of extreme heat toward Iberia, France, southeast England, and the Low Countries later in August, potentially pushing temperatures back into the low 40s across parts of France and into the low to mid-30s across southeast England, even as a brief surge of milder heat also reaches up into Ireland, Northern Ireland, and Scotland once or twice before the month is out. Forecasters have also flagged the possibility that tropical moisture and storminess could get drawn northward into parts of Europe later in the month, potentially bringing wetter conditions to Ireland, Northern Ireland, Scotland, and Northern England, even while much of England and Wales stay comparatively dry. A genuinely mixed and regionally complicated picture rather than a single, uniform pattern change, sweeping across the whole continent at once. Underlying all of this regional detail is a broader, more troubling trend that's worth putting in historical context, because 2026 is not an isolated hot summer arriving out of nowhere. It's the latest entry in a rapidly lengthening recent run of severe, often record-breaking European heat events. The summer of 2025 delivered its own brutal sequence of heat waves, with national maximum June temperature records broken in both Portugal and Spain, as readings surpassed 46 degrees Celsius, alongside regional records broken in at least 10 other countries across the continent. Spain's National Weather Agency subsequently confirmed that the summer of 2025 had been the country's hottest on record, with average temperatures across June through August reaching 24.2 degrees Celsius. Researchers who studied that summer's death toll found that by mid-September 2025, roughly 16,500 people across Europe may have died as a direct result of climate change amplifying that summer's heat, a figure representing an estimated 68% of all heatwave-related deaths recorded across the continent that year. The summer before that, in 2024, was similarly devastating. That year's heat waves swept across an enormous stretch of the continent, from Greece, Italy, and Ukraine through Croatia, Serbia, North Macedonia, Moldova, Bulgaria, Albania, Bosnia and Herzegovina, Montenegro, and Romania, all the way to Spain, Portugal, and the United Kingdom, with the single highest temperature recorded that summer reaching 46.8 degrees Celsius at Agios Vasileios in Cyprus. A subsequent report published in the journal Nature Medicine found that Europe suffered more than 62,700 heat-related deaths as a result of that summer's extreme temperatures, an almost unimaginable toll for a single season of hot weather across a continent generally considered wealthy and well-equipped to handle extreme conditions. Even this year's summer arrived early and aggressively. According to tracking of the 2026 European heatwave season, the very first major heat event of the year struck starting on May 22nd, an historic record hour, shattering heatwave that pushed temperatures 10 to 15 degrees Celsius above normal across large parts of the continent, breaking all-time records for the highest temperatures ever recorded during May, and springtime more broadly across the affected countries, with a peak reading of 40.3 degrees Celsius recorded at Mora, Portugal on May 27th. That heatwave struck Spain, the United Kingdom, Germany, France, and Ireland particularly hard. The climate scientists specifically pointed to climate change as a contributing factor behind such an unusually early and severe onset of summer heat, months before the season would traditionally be expected to bring conditions anywhere close to that intensity. Western Europe bore the brunt of that spring heat wave, with France, the United Kingdom, and Ireland all recording genuinely record-breaking temperatures, and even typically mild Brussels saw local readings climb to 31 degrees Celsius in late May. Laid end to end, that sequence, an unprecedented record-breaking heat wave in May, followed by a summer now already on its fourth distinct major heat event by early August, illustrates just how compressed and relentless Europe's extreme heat calendar has become in recent years. What used to be occasional headline-making anomalies, a single brutal heat wave remembered for years afterward, have increasingly become a recurring, near-continuous feature of the European summer, arriving in waves rather than isolated episodes, each one layering additional strain onto soil, rivers, infrastructure, and public health systems that may not have fully recovered from the previous one before the next arrives. That accumulated strain helps explain why officials and meteorologists have been so consistently emphatic about practical health guidance throughout this current heat dome. During heat waves, health authorities recommend scheduling any strenuous physical activity for the early morning or evening hours when temperatures are at their lowest, drinking water regularly throughout the day rather than waiting until feeling thirsty, and paying particularly close attention to elderly people, young children, and anyone living with cardiovascular or respiratory conditions, since those groups face dramatically elevated risk during extended periods of extreme heat. The scale of the death tolls recorded across the 2024 and 2025 heatwave seasons underscores that this guidance is not merely precautionary boilerplate. It reflects a genuine, recurring, and substantial public health emergency, playing out across the continent almost every summer now, one that disproportionately claims the lives of exactly the vulnerable populations that heat advisories consistently single out for extra caution. The current heat dome's connection to wildfire risk and worsening drought conditions is just as direct and just as serious. Photographs from Cotignac, France, showed vegetation and tree trunks burning as drought conditions worsened following the latest heat wave, one of numerous wildfires that have broken out across multiple countries as the combination of extreme heat, low humidity, and already depleted soil moisture from earlier in the summer created ideal conditions for fast-moving fires. Authorities across affected regions have urged extreme caution around any activity that could produce a stray spark near dry vegetation, warning that something as small as sparks thrown off by machinery, a carelessly discarded cigarette, or even routine garden waste burning can be enough to ignite a fast-spreading wildfire under conditions this dry. Before any approaching thunderstorm, residents are also advised to secure loose objects on balconies and in gardens, avoid sheltering beneath isolated trees, stay out of open water, and avoid leaving vehicles parked in low-lying areas that could flood rapidly if a storm does bring a sudden burst of heavy rain, since the same blocking pattern responsible for extended heat can also produce unusually intense, localized downpours once it finally begins to break down. Beyond the immediate public health toll, this stretch of compounding heat and drought is also inflicting a considerable, if less immediately visible, economic cost across the continent. Farmers across southern and central Europe have reported sharply reduced yields for water-intensive crops, including corn, sunflowers, and various fruit and vegetable harvests, as depleted soil moisture and restricted irrigation allowances in drought. Affected regions cut directly into agricultural output during a critical stretch of the growing season. Rivers that serve as vital transport corridors for European commerce, including stretches of the Rhine and the Danube, have seen water levels drop low enough in past dry summers to restrict barge traffic, carrying everything from coal and grain to industrial components, forcing shippers onto more expensive road and rail alternatives, and similar restrictions have already been reported in some sections this summer as river levels continue running below seasonal norms. Hydroelectric power generation, and the cooling water supplies that many conventional and nuclear power plants rely on, can also come under strain during extended heat and drought events, occasionally forcing utilities to reduce output at specific facilities precisely when demand for electricity, driven by widespread air. Conditioning use is running at its highest point of the year. None of these secondary effects tend to generate the same kind of urgent headlines as a wildfire racing through a hillside or heat-related death toll, but taken together, they represent a substantial and recurring drag on European economies that compounds year after year as this kind of extreme summer weather becomes less of an occasional anomaly and more of a routine feature of the seasonal calendar. Heat and drought have not been the only extreme weather story unfolding across Europe over the past year either. The 2025 to 2026 European windstorm season, now in its 11th year of the continent's coordinated severe weather naming program, has already produced 39 separate named storms, with more than 487 fatalities recorded across the season so far. The strongest storm of the season by central pressure, Storm Joseph, registered a minimum pressure of 9 out of 39 hectopascals, an extremely deep low reading indicative of a genuinely powerful system, while the strongest individual wind gust recorded during the entire season, associated with Storm Amy, reached 139 miles per hour at Folgefonna, Norway, among the most extreme wind readings recorded anywhere in Europe in recent memory. That windstorm season, running roughly from September through the following August, sits as a stark reminder that Europe's weather volatility this year has not been confined to heat alone, but has also included an unusually violent and deadly stretch of Atlantic storm activity layered on top of it. Taken together, this creates the genuinely complicated two-part story currently unfolding across the continent. On one hand, Europe is living through an intense ongoing heat dome, its fourth major heat wave of the summer, driven by a textbook omega block, patterned and amplified by a rapidly intensifying El Niño event, on top of an already unusually hot and dry start to the season. On the other hand, forecasters are now tracking real signs of change arriving over the coming weeks, not necessarily a full retreat from summer heat altogether, but a genuine shift in exactly where that heat settles, moving from its current concentration over Central, Eastern, and Southeastern Europe toward a renewed push into Iberia, France, and southern Britain later in August, even as some signs point toward a wetter, stormier pattern finally reaching Ireland, Scotland, and northern England after weeks of persistent dryness. It's worth grounding all of this in what it actually looks and feels like on the ground in some of the specific cities and regions caught in the middle of it. In Madrid and across much of central Spain, residents have grown accustomed in recent summers to adjusting daily routines entirely around the heat, shifting outdoor work, deliveries, and even school activities to the earliest morning hours before temperatures climb into the mid-30s and beyond by midday, while shops and offices increasingly stagger their hours to allow employees to avoid commuting during the most dangerous stretch of the afternoon. In Rome and across much of Italy, the combination of extreme heat and a steady stream of tourists unfamiliar with local conditions has repeatedly strained emergency medical services during past heatwave summers, with local health authorities issuing repeated public reminders about hydration and sun exposure specifically aimed at visitors who may not appreciate just how differently a Mediterranean heatwave behaves compared to a hot day back home. Further north, cities like Berlin and Warsaw, historically far less accustomed to sustained extreme heat than their southern counterparts, have had to rapidly adapt in recent years as heat waves increasingly push deep into Central and Eastern Europe, regions where air conditioning penetration in homes and public buildings has traditionally been far lower than in the Mediterranean, leaving residents there in some ways more vulnerable to a serious heat event precisely because the infrastructure to cope with it has not caught up with how often these events are now occurring. Meanwhile, across the Atlantic-facing edge of the continent, Ireland, Scotland, and northern England have spent much of this same stretch dealing with an entirely different problem: a marine heat wave affecting the waters surrounding the British Isles, contributing to unusually mild, dry conditions on land, even as the rest of the continent bakes under far more extreme heat. That marine warmth carries its own complications, since warmer surface waters can help fuel more intense rainfall when storm systems do eventually arrive, meaning the drier, milder stretch currently affecting Ireland and Scotland could give way relatively quickly to a burst of much heavier, more disruptive rain, once the broader continental pattern finally shifts and draws moisture northward later in August, exactly the kind of abrupt transition from one extreme to another that has increasingly come to define European weather in recent years. Looking at the bigger picture, this summer's pattern, extreme, record-challenging heat concentrated in intense pulses, punctuated by brief periods of severe storms, layered on top of a broader multi-year trend of increasingly frequent atmospheric blocking events, fits squarely within what climate scientists have been warning about for years regarding how a warming climate reshapes extreme weather, even when any single heat wave or storm can't be attributed entirely to climate change on its own. A general seasonal signal pointing toward a warmer than normal August across the Mediterranean, for instance, does not mean every single day across that entire region will be uniformly hot, and a scattered thunderstorm forecast for a broader region might pass only a few kilometers from any individual location, missing it entirely while drenching a neighboring town. That level of local unpredictability is precisely why forecasters continue urging people to monitor short-term, localized forecasts closely, even while tracking the broader seasonal pattern, since the two operate on genuinely different scales and don't always translate directly into what any one person will personally experience outside their own window on any given afternoon. Looking at the bigger picture, this summer's pattern, extreme record-challenging heat concentrated in intense pulses, punctuated by brief periods of severe storms, layered on top of a broader multi-year trend of increasingly frequent atmospheric blocking events, fits squarely within what climate scientists have been warning about for years regarding how a warming climate reshapes extreme weather, even when any single heat wave or storm can't be attributed entirely to climate change on its own. The nearly tripled frequency of blocking patterns identified by recent research offers one specific, measurable mechanism connecting the broader warming trend to the kind of persistent, damaging weather extremes Europe has now experienced in back-to-back summers, each one seemingly intensifying on the last, each one arriving earlier in the year, and each one leaving behind a mounting human and economic toll that shows no clear sign of easing off. A decade or two ago, a single summer producing 4 distinct major heat events, back-to-back years of tens of thousands of heat-related deaths, and an 11th consecutive season of a formal, coordinated windstorm naming program would have registered as an extraordinary one-off convergence of bad luck. Increasingly, it reads instead as simply what a European summer now looks like, a recurring, multi-front weather emergency that arrives earlier, hits harder, and takes longer to fully resolve than it once did, even as the underlying seasonal machinery, the jet stream, the Atlantic storm track, the broader Pacific El Niño cycle, keeps producing recognizably similar patterns to the ones meteorologists have studied for generations. What has changed is not the basic physics of an omega block or the mechanics of a windstorm forming out over the North Atlantic. What has changed is how often those familiar patterns now arrive stacked on top of a warmer baseline and how much more damage they do each time they land. For the tens of millions of people currently living through this fourth heat wave of the summer, whether they're sheltering indoors in Madrid or Bucharest during the peak of the afternoon heat, watching wildfire smoke rise over the hills near Cotignac, or bracing for storms finally rolling in off the Atlantic toward Ireland and Scotland after weeks of drought, the practical reality remains the same one meteorologists have been repeating throughout this entire stretch. Stay hydrated, watch out for the most vulnerable people around you, take fire risks seriously in dry conditions, and keep a close eye on the more immediate, localized forecast, because even as the continent's broader weather pattern genuinely begins to shift over the coming weeks, exactly how and exactly where that shift plays out remains, as always with weather at this scale, a story still being written 1 week at a time.